Hi, and welcome to EazyML, a machine learning platform. The purpose of EazyML is to democratize machine learning so that even if you're not a data scientist, you can still receive all of the benefits machine learning has to offer. EazyML will enrich your life, automate repetitive tasks, and allow you to be much more productive in your life. Let me show you how it works. This is a platform that requires supervisory learning. You don't need to be afraid of that word. All it means is that you'll first have to train EazyML, and for that, you'll need training data. Here is the training data. As you can see, it's a simple Excel spreadsheet. Here, we are trying to predict voice quality given all the input parameters, like codec, network delay, network packet loss, voice over IP gateway dejitter buffer delay at the voice over IP gateway dejitter buffer loss percentage, and in the end column G, you predict the voice quality. In this case, it's training data because EazyML has to learn before it can predict your world. So, it's already labeled for training. Like this is OK quality, good quality, poor quality, OK quality. So for these 729 codec and 88 milliseconds and other values, including 0.1%, the voice quality that EazyML has learned to predict is that it's to be OK. Here's the training data. This is what EazyML is going to use to learn about your world before it becomes intelligent to predict. So what are we waiting for? Let's go ahead and try this out. This is the EazyML platform, which has a single sign-on. You will get your own login, and it says accelerated mode and detailed mode. This is the EazyML platform, very simple and straightforward. Now, the beauty of EazyML is that it's very transparent. It's not a black box. Everything is exposed to you. For instance, if you're wondering what the accelerated or detailed mode is, don't worry. Just hit the Help button, and a dialog box will pop up and tell you that the accelerated mode is when EazyML just rushes through without stopping at every step to tell you what it's doing. It runs in accelerated mode. Got that? Okay, let's go for accelerated mode to save time. The next 3 steps are very simple. You upload the training data, you build a statistical model, and then you use it to predict your world. All right, let's go to the first step. Training data. We just went through it. It was a very simple Excel spreadsheet so that EazyML can learn about VoIP quality and how to predict voice quality. Then, once the model is ready, you build it, and it can then go and predict it. Let's go ahead. Choose the file, and just go ahead and choose the file that we had. Remember, it was the Excel spreadsheet. I was showing it earlier. I'm uploading it now. Now it's analyzing your training data, distribution, characteristics of the data, and wow, it finally stops. Now EazyML says, hey, I need to know what you're trying to predict here. Well, I'm trying to predict the voice quality. All these input parameters, codec network delays and loss, dejitter delays and loss, predict voice quality in the end. Okay, cool. Let's keep moving. Let's skip the visualization in order to save time, but you can visualize plot data and see how they correlate. Wonderful. Now EazyML has processed your input training data, cleansed it, normalized it. It's ready now. It's ready to build models. It started to build models, derived predictors, independent predictors, outliers, and lo and behold, There it is, building various statistical models. Whichever is most accurate for your particular project is the one EazyML will select for your prediction. In this case, it's the support vector classifier that is the most accurate. Accuracy for this is 0.75 in a kappa, which is also a more sophisticated measure of accuracy. And for the curious mind, again, it's a very transparent machine. Just click the Help button and it will tell you what kappa is. You need more detail? Click More Help and it will tell you in more detail. So good. Our models are built. We are going to use the one that won the race, which is the support vector classifier, to make further predictions. Didn't I tell you that EazyML is a very transparent machine learning platform? Look at this. It's even telling you which input variable, which predictor played the most important role predicting the outcome in building the model. So network delay was numero uno. That was the most important predictor, followed by the dejitter buffer delay, and codec, dejitter buffer loss, and network loss. Alright, so we got the relative importance in terms of making the predictions, so let's keep going. Models are built, and now it's time we start doing the actual stuff. Yes, I do want to predict. Aha, so it says upload new data, so EazyML can predict now. So here's what we will do. Here's the test data, or the data for prediction. Notice it's got all the input parameters, predictors, or variables, codec, network delay and loss, dejitter buffer at voice over IP gateway, its delay, dejitter buffer at voice over IP gateway, its loss. This is what the EazyML has to predict. In the training data, it has OK, good, or poor populated here so that EazyML could learn. Now that it's ready and has learned, it doesn't need this. This is what the IT statistical model that you built has to predict. Notice that this is blank. Alright, let's now upload this file and watch EazyML make predictions. So, let's upload. Okay, so we're going to choose the file that we were just looking at. And here's the prediction. For all of these input codec, network dejitter, and loss coding decoding cycles, here are the predictions of voice quality. Okay, good, poor. Notice that this is good, and the next one is predicted poor. But if you look closely, they have all the same parameters. 97 milliseconds network delay, 0.4% loss for both, 66 milliseconds dejitter buffer delay for both, 0.2% loss for both in dejitter buffer for voice over IP gateway. Ah, the codec is different. You've got the non-lossy G711 codec versus the non-lossy G729 that compresses the voice a lot. G711 is a superior codec for the same parameters. It's got good voice. An inferior codec, G729, that's lossy results in poor voice for the same parameters. Let's say you have a question. Remember transparency, the most important thing about EazyML? So why did we predict good for the G711? Does EazyML understand that the codec is what made the big difference? Let's go find out. EazyML is going to tell us why it made that prediction. So you're going to say yes to this, because we want to find out about this guy. Remember the G711 and that it predicted good. Choose that. And you can see that the number of coding, decoding cycles, and codec played a very important role in ensuring that EazyML predicts good voice for the G711. Codec clearly plays a very important role. See how EazyML explains this for each and every prediction? Not only is it accurate in making predictions about voice quality, but it also explains it well for you. I hope this helped you. Use EazyML to automate your troubleshooting operations and predict your world. To learn more about EazyML and how you can integrate it into your life to eliminate repetitive tasks and help with your productivity, please visit the links in the comments below. Thanks for watching.